Good morning all of you. I completed the types of side distances and factor affecting the stopping side distance in the last session. Now I proceeding with the next topic, that is analysis of stopping side distance today. Okay. Analysis of SSD. Analysis of SSD, where SSD is stopping side distance. Okay. The stopping side distance is the sum of lag distance and braking distance. The stopping side distance SSD, the SSD is the sum of number 1, it is lag distance, and number B, it is braking distance. Braking distance. Okay, the stopping side distance is the sum of lag distance and braking distance. Then what do you mean by this lag distance and what do you mean by the braking distance? It's very simple. Okay, the distance travelled by the vehicle during the reaction time T, that is lag distance. That is lag distance. Distance travelled by the vehicle during reaction time T, that is lag distance. And the braking distance, it is the distance travelled by the vehicle from the instant of the effective brake application to the instant of the vehicle comes to a dead stop position. Okay, that is the braking distance. This is the distance travelled by the vehicle from the instant of effective brake application to the dead stop position of the vehicle. Dead stop position of the vehicle. Okay, it's very simple. During the reaction time, the driver has to think whether he has to stop the vehicle or he has to continue to move further. Okay, that is the reaction time. Okay, during that time he has thinking whether I to stop or whether I continue to move. Okay, during that time your vehicle may cover some distance. The vehicle may travel some distance. That distance is called lag distance. Okay, let's assume that during the reaction time he has decided to stop the vehicle. Then from the instant of time he apply the brake effectively. To the vehicle comes to a dead stop position. Okay, then also some distance is covered by the vehicle. That distance is called braking distance. Means from the application of brake to the vehicle comes to a dead stop position. The vehicle covered some distance. That distance is called braking distance. And your stopping side distance is the sum of lag distance and braking distance. Sum of lag distance and braking distance. Is it clear? Okay. I will take up one by one lag distance and braking distance. If I took lag distance, okay, usually during the reaction time the vehicle keeps on moving with a constant design speed. During the reaction time, the vehicle keeps on moving with the constant design speed. Let v is equal to your design speed of the vehicle, in terms of meter per second, and t is equal to reaction time of the driver in terms of seconds. Therefore, lag distance is equal to v into t in terms of meter. That is v in terms of meter per second and t is in terms of second. Then we get the answer in terms of meter. Is it clear? We know that the distance is the product of speed and time. Distance is the product of speed and time. See here, the lag distance is the product of distance, that is speed, the design speed in terms of meter per second, and the reaction time in terms of second. So the product of v and t will give the lag distance. Is it clear? And for the calculation purpose of stopping side distance, the IRC has recommended the value of reaction time of the diver. It is 2.5 seconds. 2.5 seconds. Okay, this is the value of reaction time for the calculation of stopping side distance. Okay, then the lag distance is equal to Vt. V into t. So, if V in terms of kilometer per hour, kmph, if V in terms of kilometer per hour, then lag distance is equal to 0.278 V into t. Then this is also in terms of meter. Okay, if V in terms of kilometer per hour, the first one V multiplication of t, that is when V in terms of meter per second, and here the 0.278 V into t, here the V in terms of kilometer per hour. And we know the conversion of the speed from kilometer per hour to meter per second. No, if you want to convert the speed in terms of kilometer per hour to meter per second, then whatever the speed they are given in terms of kilometer per hour, divide that by 3.6, then you get the answer in terms of meter per second. And if you want to convert the meter per second to kilometer per hour, then we have to multiply the 3.6 to the value of the speed, that is in terms of meter per second. Is it clear? It's very simple. If they are given 60 km per hour speed, okay, then that 60 km per hour you have to convert into meter per second, then the 60 divided by 3.6, okay, that convert your speed to meter per second. Then suppose if they are given 12.8 meter per second, 12.8 meter per second, okay, here they are given the design speed in terms of meter per second. Then if you want to convert that into kilometer per hour, then the 12.8 multiplied by 3.6, okay, then you get the design speed in terms of kilometer per hour. And here how you get 0.278? It's very simple. It is 1 by 3.6. We get about 0.2777 like that. Okay, it is 0.278, 1 divided by 3.6. Okay, if you want to use the V in terms of meter per second, then use this relation V into T. So V in terms of meter per second and T in terms of seconds. Then answer will get it in terms of meter. And for the lag distance, when V in terms of kilometer per hour, then you have to use the relation 0.278 V into T. Okay, here we have to substitute the value of V in terms of kilometer per hour and the reaction time T in terms of second, and the answer we get it in terms of meter itself. Okay, because of this 0.278. Is it clear? Okay, this is regarding the lag distance. And we know that lag distance, no, the distance traveled by the vehicle during the reaction time t seconds, Okay, that is the lag distance. Okay, and for the calculation purpose of stopping side distance, IRC has recommended the value of the reaction time is 2.5 seconds. Value of reaction time is 2.5 seconds. Okay. Next, I'll move on to the braking distance. Braking distance. Okay, we know the definition of braking distance, no? Means the distance travelled by the vehicle from the instant of effective brake application to the dead stop position of the vehicle, that is the braking distance. Is it clear? Let capital F is equal to frictional force in terms of kg, and small l is equal to braking distance. Small l is equal to braking distance. Then small f is the coefficient of friction. Coefficient of friction, or we can say skid resistance. Skid resistance. This is the longitudinal friction. Longitudinal friction. IRC has suggested the values of coefficient of friction for the calculation of stopping side distance from 0.35 to 0.4. Okay, and W is the weight of the vehicle. W is the weight of the vehicle in terms of kg. W is the weight of the vehicle in terms of kg. Capital F is the maximum frictional force developed in terms of kg. L is the braking distance in terms of meter. Small f is the coefficient of friction or skid resistance. W is the total weight of the vehicle in terms of kg. Okay. On the level road surface, okay, for the braking distance determination, they are going to equate the work done in the vehicle and the kinetic energy of the vehicle. Okay, for calculating or for determining the braking distance on the level road surface, what they are going to do is they are going to equating the work done in the vehicle and kinetic energy of vehicle. Okay, work done in vehicle is equal to kinetic energy of vehicle. Okay, we know that work done in vehicle is nothing but it is a product of frictional force developed and braking distance, that is F, capital F multiplication of small l, that will give the work done in vehicle. We know that force multiplied by the distance will give the work done. It is a product of force and distance. Okay, F into L will give the work done in the vehicle, and we know that the frictional force, the maximum frictional force developed is equal to your coefficient of friction multiplication of weight of the vehicle, that is capital F is equal to small f into W. Then capital F into L becomes small f W multiplication of L, because capital F is equal to small f into W, that is frictional force developed is equal to product of the coefficient of friction and weight of the vehicle, that is equal to the kinetic energy, the kinetic energy of the vehicle. We know that the kinetic energy is equal to half mv square. The kinetic energy in the vehicle is equal to half mv square, where m is the mass of the vehicle. Then the m is equal to W by Z. M is equal to W by Z means weight divided by acceleration due to gravity. Directly I write on that of W by G V square, because M is equal to W by G. The kinetic energy we know that half m is square. Okay, in place of m I written W by Z, because mass is equal to weight divided by acceleration due to gravity. Is it clear? Then see here, F into W multiplication small l is equal to 1 by 2 W divided by G multiplied by V square. Here the W get cancelled. Then L is equal to, L is your braking distance, that is equal to V square by 2GF. V square by 2GF. This will give your braking distance in terms of meter. In terms of meter. Is it clear? And this is the equation to calculate the braking distance when V in terms of meter per second. Okay, suppose if V in terms of kilometer per hour, then your braking distance becomes, if V in terms of kilometer per hour, L braking distance becomes V square divided by 254 F. 254 F. The answer we get it in terms of meter itself. So, but the thing is that in this we have to substitute the value of V in terms of meter per second, and in this equation we have to substitute the value of V in terms of kilometer per hour. Okay, how come it is 254? It's very simple. 2G. Okay, 2 and G value you know that 9.81. 2 9.81 and 3.6. Okay, 2 multiplication 9.81 multiplication of 3.6 will give us 254. Okay, this is the braking distance, okay, when V in terms of kilometer per hour, and this is for level surface, because we are assume in the level surface, okay, the braking distance can be calculated or can be determined by equating the work done in the vehicle and kinetic energy of the vehicle. Is it clear? Okay, the lag distance is equal to Vt and braking distance is equal to V square by 2Gf when V in terms of meter per second, and when V in terms of kilometer per hour, lag distance is equal to 0.278 Vt and braking distance is equal to V square by 254F. Okay, this is regarding the lag distance and braking distance. Okay. Then stopping side distance on level surface, okay, we know that stopping side distance SST is equal to sum of lag distance and braking distance, sum of lag distance and braking distance. Okay, SST is equal to sum of lag distance and braking distance. Okay, you know that on level surface lag distance is equal to V into T and braking distance is equal to V square by 2Gf. V square by 2Gf. Okay, this is the stopping site distance on level surface. The answer will get in terms of meter. Okay, where V is the design speed in terms of meter per second and T is the reaction time of the driver, and IRC has suggested the value of T for the calculation of stopping side distance, it is 2.5 seconds. Okay, and G is the acceleration due to gravity, that is 9.81 meter per second square. Then F is the longitudinal friction. Okay, the value of F is depend on the design speed and usually it is from 0.35 to 0.4. Okay. And this is the stopping side distance relation when V in terms of meter per second. If V in terms of kilometer per hour, then stopping side distance is equal to 0.278 Vt plus V square divided by 254 F. 254 F. Okay, in this also the answer we get it in terms of meter, but the thing is that we have to substitute here the value of V in terms of kilometer per hour, in terms of kilometer per hour. Is it clear? Okay, this is regarding the stopping side distance on level surface, stopping side distance on level surface. Okay. Then stopping side distance SSD on slopes. On slopes. It may be a upward slope or it may be a downward slope. That is upward gradient or downward gradient. We can say that ascending gradient or descending gradient. Okay. First I will take for ascending gradient, say plus n%. Ascending gradient means it is an upward gradient and descending gradient means it is a downward gradient. So suppose if the stretch having an ascending gradient of n%, for the ascending gradient you have to use the positive sign and for the descending gradient you have to use the negative sign. Okay, if the stretch having the ascending gradient of n%, and we know, you must know that for a slopes, okay, there is no change in the lag distance, it is only change in the braking distance. Okay, the lag distance will be same for the level road surface and at slopes. Okay, only the braking distance vary on level road surface and slope surface. Okay, so for an ascending gradient of n%, the braking distance L is equal to V square by 2G F plus N divided by 100 plus N divided by 100. What is that? It is n percentage, no? N percentage. If you want that percentage in terms of fraction, that is divided by 100, no? That is n divided by 100. That is also written as 0.01 n. 0.01 n. Was it clear? Okay. This is regarding the braking distance, okay, for a ascending gradient of n%. Okay. Similarly, for descending gradient, minus n%, your braking distance V square divided by 2G F minus n divided by 100. Minus n percentage, no? So percentage in terms of fraction, it is 1 divided by 100, that is minus n divided by 100, or we can say minus 0.01 n. Minus 0.01 n. Is it clear? Therefore, the stopping side distance on slope, that is SSD is equal to Vt plus V square by 2G F plus or minus n divided by 100. Plus or minus n divided by 100. Okay, if you use this relation to find out the stopping side distance on slopes, okay, the answer will get it in terms of meter, where Vt is the lag distance, V square by 2G F plus or minus n divided by 100 is the braking distance on slopes. And here use a plus when ascending gradient is given, use a minus when descending gradient is given. 2Gf plus or minus n by 100, no? Use plus when ascending gradient is given and use minus when descending gradient is given. Okay, and this is the relation to find out the stopping side distance on slope when V in terms of meter per second. Suppose if the V in terms of kilometer per hour, then this relation becomes 0.278 Vt plus V square by 254 F plus or minus n by 100. Okay, that is regarding the stopping side distance on slopes. Stopping side distance on slope. And here the value of F, the coefficient friction, or we can say that longitudinal friction, okay, that is depend on design speed, no? Okay, the values of F, they may not given in your stopping side distance problems. Okay, you should know value of F for the respective design speed. Okay. The IRCA has recommended the values of coefficient of friction F for calculating the stopping side distance. Okay. Values of F for stopping side distance. values of F for stopping side distance, and these values were recommended by Indian Roads Congress IRC. Okay, it is depend on design speed in terms of kilometer per hour and value of F. Okay, if the design speed is about 20 to 30 kilometer per hour, then your longitudinal friction it's about 0.4. It's about 0.4. And if the design speed is about 40 kilometer per hour, then your F value is 0.38, and design speed is about 50, it becomes 0.37. If the design speed about 60 km per hour, it becomes 0.36, and if the design speed about 65, it becomes 0.36, and if the design speed about 80, okay, it is 0.35, and design speed about 100 and above, it is 0.35. It is 0.35 only. Okay, for the 20 to 30 design speed, the coefficient of friction value is 0.4. For the 40 km per hour, it is 0.38. For 50, it is 0.37. For 60, it is 0.36. For 65, it is 0.36. And for 80, it is 0.35. And for 100 and above, for 100 and above design speed, the value of F is 0.35 only. Value of F is 0.35 only. Suppose if the design speed in between the two values, suppose for 60 it is 0.36 and for 80 it is 0.35. No, if they are given 70 km per hour speed or 75 km per hour speed, then you have to do the interpolation between those two values. Then you have to do the interpolation. Suppose here for 80 it is 0.35, for 100 above is 0.35. Okay, if we get any value between that, we will get 0.35 only. Okay, if they given 100 is 0.35 and 80 is 0.35, then for 90 also it is 0.35 only. For 85 also it is 0.35, because it's one and the same. But here is varies. 65 it is 0.36 and 80 it is 0.35. If the design speed is about 70 or 75, okay, it varies between 0.36 to 0.35. Is it clear? Okay, these are the values of F, that is the coefficient of friction or longitudinal friction, for the calculation of stopping sight distance. Okay, this is regarding the analysis of stopping sight distance. This is regarding the analysis of stopping sight distance. Okay.